Hello class and welcome to section 8.2. Today we're going to look at adding and subtracting rational expressions. So to remember to be a rational expression, that means that you can be written as a ratio or as a fraction. So we're going to be adding and subtracting fractions today. So let's look at the example that we have listed here. In order to produce a picture that is in focus, the distance between the camera lens and the film Q must be controlled so that it satisfies a particular relationship. If the distance from the subject to the lens is p and the focal length of the lens is f, then the following formula, which they give us there, can be used to determine the correct distance between the lens and the film. So we're going to go ahead and solve for 1 over q, and we're going to do it as if 1 over f is equal to 5 over 6 and 1 over p is equal to 1 over 4. So we're finding 1 over q. So 1 over q will equal 1 over f is 5/6 minus 1 over p is 1/4. All right, so what we need to do is in order to add and subtract fractions, we need to get a common denominator. So that is what is called finding the least common multiple. So what is the smallest number that both 6 and 4 would multiply to be? Well, I could get both of them to multiply to 12. So in order to get 6 to 12, I would multiply by 2. If I do it to the denominator, I also have to do it to the numerator. To get 4 to 12, I would have to multiply it by 3. So I'd have 1 over q is equal to 10 over 12 minus 3 over 12. Now thinking back, whenever I'm going to subtract fractions, okay, as long as my denominators are exactly the same, I can subtract the numerators. So it'd be 10 minus 3, which gives me 7 over, and my denominator stays the same. So 1 over q is equal to 7 over 12. Okay. Let's go ahead now and look at what is the least common multiple of polynomials. Okay. In order to find the least common multiple of polynomials in factored form, you need to go ahead and contain each factor the greatest number of times the factor appears. Okay, so the greatest number of times the factor appears. So for instance, we just found the least common multiple of 6 and 4. We said it was 12. Okay, let's walk through this a little bit. If I need to, I can do my factor tree of 6. Okay, that's going to be 2 times 3. So 6 is 2 times 3. And 4 is really 2 times 2. Okay, so it's going to be the greatest number of time the factor appears. So if I break this down, okay, I'm going to look at my 6. How many 2's are there here? Well, there's 1 2 here, and if I look to the right, there's 2 2's here. So the greatest number of times that it occurs is twice. So to find my LCM, I'm going to write down 2 twice, so 2 times 2. Then I look at my other factor. My other factor is 3. Well, there's 1 3 here, and there's no 3's here, so I'm going to multiply by 3. Then I would go ahead and multiply. 2 times 2 is 4. 4 times 3 is 12. So that's another way that you could get to 12 when you're dealing with more complex problems. I understand that we feel pretty confident with 6 and 4, but in case you didn't, that's how we can break it down. The other one is if we have polynomials. We're going to need to factor them. So if I have p minus 3, there's no factoring that needs to be done there, but p squared plus 6, p minus 27 can be factored. What multiplies to negative 27 but adds to 6? Positive 9 and negative 3. So now I go ahead. I have 1p minus 3, and on this piece I have 1p minus 3, so I write down the greatest number, which is just once. So my LCM would be p minus 3 times. Now I will go ahead, and there's no p plus 9, but there is one p plus 9, so I'm going to write down p plus 9. So this is my least common multiple for these polynomials. Okay. So in order to find the LCM, you want to make sure you factor if you need to, and then multiply each polynomial by the factors it is missing, and then we're going to use the greatest common factor that number of times it appears. So let's just go ahead and look at some examples. Okay. Example 2. I would go ahead and just break this one down. Okay, we have 12. That's going to be 2 times 6, which breaks down into 2 times 3. So there's 12. Now let's go ahead and do 27. That's really 3 times 9, and then that breaks down into 3 times 3. And then if we go ahead and take a look at 18, 18 is 2 times 9, and that breaks down into 3 times 3. So to figure out my least common multiple, okay, there is 2 2 2's here, there is no 2's here, and there is 1 2 here. So I write down the greatest number of 2's for each one, so that would just be 2 2's. So it's 2 times 2. Now I look at my 3's. There's 1 3 here, there's 3 3's here, and there's 2 3's here. So which one has the greatest number of 3's? Here, and there's 3 of them, so I write down 3 3's. Okay, we've got 2's and 3's, and that's it for here. Now, that's going to be my number that's going to be in front for my least common multiple. Now I look at my variables, and we always write down the greatest. So this one's a squared, this one's really a to the first, and this is a to the fifth. So my greatest is a to the fifth. B to the fourth, no B, B to the second. So the greatest is B to the fourth. And then C's. There's no C here, C to the third, C to the first, so the biggest is C to the third. Then I would go ahead and I would say, well, 2 times 2 is 4, times 3 times 3 times 3, type that into your calculator, and you would get that it's 108. A to the fifth, B to the fourth, C to the third. So there is my least common multiple for those 3 monomials. Okay. Example 3, I would recommend pausing the video and giving this one a try on your own. Okay. Otherwise, I'm going to go ahead and do example 3. So we're going to break it down just like we did before. So this one's going to break down into 2 times 3. 42. 2 times 21. That breaks down into 3 times 7. 36 is 3 times 12. Then 2 times 6. And then this is 2 times 3. So there, that is all broken down. So let's find my least common multiple for this one. So there's 1 2 here, there's 1 2 here, and there's 2 2's here. So I'm going to write down 2 2's because that's the greatest number. There's 1 3 here, there's 1 3 here, and there's 2 3's here. So I'm going to write down 2 3's. No 7's, 1 7, no 7. So I write down 1 7. And then I go ahead and I look, well, there's an m to the third, m to the first, m to the third. So I write down m to the third. N to the fifth, n to the first, n to the fourth. The biggest one is n to the fifth. Then p's, there's no p here. P squared, p to the first, so my largest is p squared. And then we take and type in our calculator 2 times 2 times 3 times 3 times 7, which gives us 252. And then I write m to the third, n to the fifth, p to the second. That is my least common multiple, for those 3 monomials. All right, so we're moving away from monomials. Remember, mono means 1, okay? There was only 1 piece. Here we're going to go ahead and move to polynomials where there's more than 1 piece. So we're going to need to factor, okay? So if I look at this first one, I can see that there's a p to the third, p squared, p. So I can take out a p. Okay, so it's going to give me 5p plus 6. And now I'm going to go ahead and factor what's in parentheses down. What multiplies to 6 but adds to 5? Well, 2 times 3 multiplies to 6 but adds to 5. Now I go ahead and look at my other polynomial. And in this case, I would factor it. What multiplies to 9 but adds to 6? Well, 3 times 3 is 9, but it also adds to 6. So now I go ahead and I write down my least common multiple. There's 1 p here, there's no p's here, so I write down the biggest number, which is 1. I have p squared and no p squared, so I write down 1p, sorry, not p squared, p plus 2. Now there's 1p plus 3 here, there's 1p plus, sorry, there's 2p plus 3's here, so there's 1 here, 2 here, so I write down the biggest number, so I write it down twice. So my least common multiple would be p times p plus 2 times p plus 3 times p plus 3. One way that would probably be written to simplify this is I would write it as p plus 3 squared. So this would be my least common multiple for example 4. Okay, let's go ahead and look at example 5. We're going to go ahead and factor this one. So if I look at the left-hand side, I just need to factor it. So what multiplies to 4 but adds to negative 4? Well, negative 2 times negative 2 gives me positive 4, but when I add them, I get negative 4. Now I'm going to go ahead and look at this piece on the right-hand side, my polynomial, and I would see that each one has a q, and I labeled this wrong. Should have been a q, right? Not p's anymore. All right, so moving on, now I look here, I'm going to factor out a q. So I would q, then I would have q squared minus 3q plus 2. And now I need to factor what's on the inside here. So it multiplies to 2. Well, that's easy. There's only one thing that multiplies to 2, 2 times 1, but adds to negative 3. Well, to get to negative 3, they both need to be negative. Okay, so now that I have my factored form, I would go ahead. I have on the left hand 2q minus 2's and 1q minus 2 on the right. So I'm going to write down the greatest common, or the greatest number of numbers. So there's 2q minus 2's. Then there's 1q here, no q's here, so I write down 1q. And then q minus 1. No q minus 1, so I write down 1. And then I would just probably simplify this to q minus 2 squared times q minus 1. And there would be my answer for example 5. All right, example 6 then. Same idea, factor them first. So the left-hand side, I need to go ahead and take out an x. So I would have what multiplies to negative 2. Well, the only thing that multiplies to 2 are 2 and 1, and adds to negative 1. So I'd have to have negative 2, positive 1. Okay, so there's my left-hand side factored. Now I need to go ahead and factor my right-hand side. So what multiplies to 4, but adds to negative 4? Negative 2 and negative 2. Okay, so using those values, I'm going to go ahead, look in here, find my least common multiple. There's 1x here, no x, so I write down 1, the greatest number. There's 1x minus 2, and there's 2x minus 2, so I write it down twice. And then there's 1x plus 1, and there's no x plus 1, so I write down once. And same thing, I would simplify. X minus 2, since there's 2, I can write it as x minus 2 squared. And there is my least common multiple for example 6. Okay. Example 7 is maybe a little bit trickier because we have an a value that's greater than 1, okay, because we have this 2 out in front here. So let's go ahead and just look at 7. There's a k to the third, a k squared, and a k. So I can factor out a k. So I would have 2k squared minus 5k minus 12. Okay, now I need to factor this piece. You can either use guess and check, or you can use grouping. It's up to you. I will quickly refresh on grouping in case you want to use grouping. Okay, so we take our a times our c value, which gives me 2 times negative 12, which gives me negative 24. Maybe I'm going to write it right here. Now I say, what multiplies to negative 24, but adds to negative 5? Okay. Well, 8 times 3 is 24. So I would have negative 8 times 3. So that's where we rewrite. So I keep my k out in front. So it's going to be 2k squared minus 8k plus 3k minus 12. Then I go ahead and I'm going to group what's on the inside. So I look at the first 2 and I look at the last 2. So I'm going to keep the k here. So I would have, I can take out a 2k, then I would have k minus 8 divided by 2 is 4, and then k divided by k is 1. Okay, plus, out of here, I can factor out a 3. And then remember with grouping, okay, we can go ahead and I'm going to have this k out in front. If there is exactly what's in the same parentheses, it's k minus 4. And then what's on the outside is our other set of parentheses. So it's 2k plus 3. Okay, so there's my first polynomial factored. Now let's go ahead and look at my second polynomial. So we have, I'm just going to rewrite it over here, k to the third minus 8k squared plus 16k. So I'm going to factor out a k. So I would have k squared minus 8k plus 16. What multiplies to 16 but adds to negative 8? Negative 4 times negative 4 gives me 16, but if I add them together, I get negative 8. So let's go ahead and find my least common multiple for the 2. There's 1k here, so I write down 1k. There's 1k minus 4, there's 2k minus 4, so I write down the bigger number, so there's 2 of them. And then there's 1 2k plus 3. There's no 2k's plus 3, so I write down 1 2k plus 3. And that is everything. So my last step is just to write it as k minus 4 squared times 2k plus 3. And that is my least common multiple for example 7. Okay. We're going to go ahead and end the first part of the notes video right here. I would recommend taking a little break, and then when we come back, we're going to go ahead and do adding and subtracting rational expressions. So if you do have any questions on the front side, please be sure to write them down. Ask me tomorrow in class. Otherwise, take a break and come back and watch part 2. See you then.